Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic electrical and electronics engineering. We'll dive into key concepts like guidelines for voltage and current sources, dependent and independent sources, units and dimensions, source conversion. Slide 1. Voltage and current sources. Definition of voltage source. A voltage source provides a constant voltage across its terminals, regardless of the current drawn. Definition of current source. A current source delivers a constant current, regardless of the voltage across it. Points to remember. 1. Ideal voltage source maintains a fixed voltage regardless of the load. 2. Practical voltage source includes internal resistance, voltage may drop with load. 3. Ideal current source delivers constant current regardless of the load. 4. Practical current source includes parallel internal resistance. 5. Examples: battery, voltage source; solar cell current output, current source. 6. Use in circuits. Both are used as basic building blocks in DC circuits. 7. Significance. Helps in power supply, circuit analysis, and signal modeling. 8. Unit of voltage, volt, V. 9. Unit of current, ampere, A. Slide 2. Independent and dependent sources. Definition of independent source. A source whose value is fixed and does not depend on any other element in the circuit. Definition of dependent source. A source whose value depends on voltage or current in some other part of the circuit. Types of dependent sources. 1. Voltage-controlled voltage source, VCVS. 2. Current-controlled voltage source, CCVS. 3. Voltage-controlled current source, VCCS. 4. Current-controlled current source, CCCS. Key points. 1. Independent sources have constant values. 2. Dependent sources are used in transistor and amplifier circuits. 3. Symbols for dependent sources are usually inside a diamond shape. 4. Examples: voltage source equals 5 volts, independent. Source value equals 2 times I, dependent. 5. Dependent sources simulate real-world active components. 6. They help analyze complex circuits using mesh or nodal analysis. 7. Provide accurate models in network analysis. 8. Useful in control systems and electronics. 9. Emphasize input-output relationship in systems. Slide 3. Units and dimensions, basic quantities. Purpose: understand physical quantities involved in electrical engineering. Key points. 1. All units are SI units. 2. Volt equals joule per coulomb. 3. Ampere equals coulomb per second. 4. Ohm equals volt per ampere. 5. Dimensional formulas help in unit verification. 6. Power equals voltage times current. 7. Consistent units avoid calculation errors. 8. Understanding dimensions aids in physical interpretation. 9. Useful for unit conversion and derivation checking. Slide 4. Source conversion, voltage left-right arrow current. Definition. Source conversion is the process of converting a voltage source with a series resistance into an equivalent current source with parallel resistance and vice versa. For voltage source to current source. Formula. I equals V divided by R. Voltage source, V, in series with resistance, R, becomes current source I with R in parallel. For current source to voltage source. Formula. V equals I multiplied by R. Current source I in parallel with resistance, R, becomes voltage source V with R in series. Key points. 1. Only linear sources can be converted. 2. Resistance value remains the same in both conversions. 3. Helps simplify circuit analysis. 4. Used in mesh and nodal methods. 5. Maintains the same external behavior. 6. Useful in designing and analyzing amplifier circuits. 7. Ensures flexible circuit modeling. 8. Helps reduce complex networks. 9. Ideal for simplifying Thevenin and Norton equivalents. Slide 5. Differences, voltage versus current source and independent versus dependent source. Voltage source versus current source. 1. Voltage source provides constant voltage, current source provides constant current. 2. Voltage source has low internal resistance, current source has high internal resistance. 3. Battery is an example of voltage source, ideal current generator is current source. 4. Voltage may drop with high load, current remains steady. 5. Used where voltage control is needed, used in current-driven devices. 6. Voltage source is more common in power systems. 7. Easier to connect in parallel, current source easier in series. 8. Power supplied depends on circuit connection. 9. Both are interchangeable using source conversion. Independent versus dependent source. 1. Independent source has fixed value, dependent source varies. 2. Independent source not affected by circuit, dependent is controlled by another parameter. 3. Independent source symbol is circle, dependent is diamond. 4. Examples: batteries, DC supply, independent, transistor models, dependent. 5. Dependent sources used in amplifier design. 6. Needed for accurate electronic simulations. 7. Make complex circuits manageable in analysis. 8. Widely used in AC-DC networks. 9. Shows cause-effect relationships in circuits.